can you imagine life without the internet? This scenario seems frightening, potentially causing a collapse in various spheres of earthly life, ranging from basic digital communication to the interruption of financial transactions that sustain global organization and economy. The sun, our reigning celestial body, the source of energy and warmth enabling the existence of living beings on Earth, is also responsible for potentially dangerous phenomena, such as solar and geomagnetic storms that can threaten life as we know it. To prevent this globally scaled catastrophe, major world powers are vigilant and focused on this threat that unfolds beyond our atmosphere, in space, and could turn against us at any moment. Are you prepared for 2024? On December 16, 2023, NASA's Solar Dynamics Observatory, the United States Space Agency, reported the occurrence of the largest solar eruption since 2017. The incident caused telecommunication failures in parts of South, Central, and North America due to the enormous amount of emitted radiation. At the time, various aviation centers of the United States National Weather Service issued alerts about interference and degradation in signal quality, causing communication disruptions on board. Although powerful, the solar flare was not directly facing our planet, which significantly mitigated its impact on the Earth's surface. These storms, also called eruptions, result from intense radiation emissions originating from sunspots. They are classified according to their intensity, ranging from Class B, the weakest, through the C scale, then M, up to X, considered the strongest. Each letter change represents a tenfold increase in the released energy. In this latest occurrence, the sun released an M-class eruption, which, although moderate, was sufficient to trigger a 2-hour radio blackout in South America and interfere with communication between aircraft pilots and ground air traffic control. While solar storms are a cause for concern for communication systems, on the other hand, the sun is responsible for creating beautiful phenomena known as the auroras borealis and australis. The last event of 2023 was described by the United States National Oceanic and Atmospheric Administration as an incredible event, and likely one of the largest solar radio events ever recorded. During these outbursts, energetic particles are released into space, traveling at speeds very close to that of light. Hence, they reach Earth quickly, in about 8 minutes, carrying a high level of radiation. These radioactive particles are detected by NASA's GOES satellite, used for the study of the sun and space weather. In addition to energetic particles, solar storms also release large coronal mass ejections. These massive eruptions loaded with ionized gas at high temperatures are thrown into space with billions of tons of plasma. This ejected material travels through space at speeds of up to several million kilometers per hour, creating a shockwave in the interplanetary medium. When CMEs interact with the Earth's magnetic field, they trigger geomagnetic storms, causing disruptions in communication and power stations, depending on their degree and intensity. Despite being rare, these frightening phenomena are part of the sun's regular 11-year cycle and occur mainly at the peak of the star's activity, known as solar maximum. Humanity is currently experiencing the so-called solar cycle 25, which officially began in early 2019 and is expected to conclude in 2029. The issue is that the Space Weather Prediction Center of the National Oceanic and Atmospheric Administration in the United States has revised its initial forecast regarding the peak of solar activity for Cycle 25. The maximum, originally predicted for July 2025, has been moved up and is expected to reach its highest level between January and October 2024. This means that more solar storms are anticipated later this year. The question is humanity prepared to face the consequences of these episodes? What can they actually cause in our life on Earth? Scientists closely monitor the movements of solar cycle 25, pointing towards the possibility of a supersolar storm occurring at any moment. Despite this phenomenon having occurred at other times in history, this is the first time humanity finds itself at a level of super-technological dependence. The most significant solar event directly observed and recorded happened in 1859 and is known as the Carrington event. Newspaper publications of that time report that polar auroras were seen worldwide, from the northern hemisphere to the Caribbean. The brightness was so intense that prospectors woke up in the middle of the night to work, and birds began to sing, believing that the light from the auroras was the sun rising on the horizon. In addition to temporal disorientation, the solar storm of 1859 also severely affected the communication system of the time, causing impacts currently estimated at $10 billion. Telegraphs across Europe and North America went haywire, were damaged, or caused small fires in telegraph stations. The energy in the air was so big that telegraphic systems continued to send and receive messages even after being disconnected from their power sources. Less severe storms were observed in 1921 and 1960, causing disruptions in radio transmissions. In March 1989, an intense geomagnetic storm left much of Quebec, Canada, without power supply. Not everyone is aware, but on July 23, 2012, a Carrington-level solar storm was observed, and with only a 2-week difference, the phenomenon did not penetrate Earth's orbit. Now, we face this possibility again. The world is not the same. Societies are fully interconnected and depend on instant and uninterrupted communication. What would happen if a phenomenon of this magnitude were to strike Earth today? Among the possible social consequences, experts warn that extreme solar storms can cause long power outages, suspension of internet services, failures in navigation systems such as GPS, disruptions in telecommunications systems, radio blackouts, destruction and satellite failures, problems in transportation systems and financial transactions. The recovery of these technologies could take weeks or months. If you've ever observed the dissatisfaction and losses caused in a few minutes of downtime in messaging apps or social media, you can imagine the magnitude of the social, material, and financial apocalypse that the lack of electricity, communication, and the internet would generate on the planet in a matter of seconds. On a personal level, radiation also poses severe health risks for airline crews, astronauts, and people living at high altitudes. This is because they can absorb the impact of this initial radioactive shock more intensely. Ultraviolet radiation, also called UV radiation, is one of the main risk factors for skin cancer, as well as the development of eye problems such as cataracts. In nature, geomagnetic storms can disorient animals that rely on Earth's magnetic field for navigation, such as large whales and migratory birds. In other words, the threat is more severe and broader than we can imagine, potentially causing unprecedented disasters for life on the planet. Communication is one of the fundamental pillars for sustaining life on Earth. Without the refinement of this element, social interactions would be limited to our physical space, and society wouldn't have the same knowledge to achieve the evolution attained thus far. In addition to being a basic necessity, communication plays a vital role in the transformation of societies. Through this activity, humans share knowledge, information, and exchange experiences, culminating in the constant advancement of technology and innovation. When we understand the extent of the threat posed by solar storms, the first question that arises is the potential risk that the event would pose to the internet. Beyond the physical health and integrity of animals, humans are primarily concerned with the social and financial chaos that societies would have to face in a cybernetic apocalypse scenario. In an era where communication and financial transactions are widely connected and interdependent, major world powers are concerned and trying to prepare for possible astronomical occurrences, especially solar storms, capable of generating crises on a global scale. Coronal mass ejections take 2 to 4 days to reach Earth's orbit. However, this time frame is not sufficient for adequate preparation on the ground or in space. Currently, companies are developing capacitors to absorb and dissipate excess absorbed energy. Devices like Faraday cages can surround important equipment, protecting them from geomagnetic shocks. However, none of these solutions is entirely efficient. On another front, scientists study and work to better understand the behavior of the sun and predict in advance the possible effects, routes, and levels of impact of solar storms. With this knowledge, it would be possible to take early disconnection actions for sensitive networks and equipment, avoiding the extent of the damage caused to our electricity and communication. The Deep Space Climate Observatory shares important data about the speed of solar flares, and there are more advanced alert systems still in development. With the right data in hand, NASA scientists and other space agencies would have the power to alert power companies, satellite operators, astronauts, and airplane pilots to prepare in advance for high-intensity radioactive events. Solar storms like the Carrington event usually happen once every 500 years. From the last occurrence until today, only 165 years have passed, opening a wide and comfortable time window for humanity to create protection mechanisms for events of this magnitude. The Sun is approximately 150 million kilometers away from Earth. Its light takes about 8.3 minutes to reach our planet. For humans, this distance seems far enough. But just looking at the vastness of the universe helps us understand how susceptible we are. Without the Sun, life on Earth would not be possible. It provides light, heat, energy, is responsible for evaporation, and various biological processes in plants and animals. Bones depend on sunlight to obtain vitamin D. Vegetables and plants depend on this star to carry out the process of photosynthesis. Going further, we must remember that the Sun is responsible for maintaining the organization of our entire planetary system. 8 planets orbit continuously around the solar gravitational orbit, ensuring that collisions between these celestial bodies do not occur. We depend on the Sun to survive, but we cannot deny the furious and unpredictable nature of the center of our universe. Faced with this perspective, scientists, authorities, and institutions work together to develop strategies and actions to reduce possible damages in the case of catastrophic solar storms. Although the scenario is indeed concerning, it is important to emphasize that scientists worldwide dedicate their lives to the constant monitoring of solar activity and its effects on terrestrial life. Awareness of the risks allows us to take a step forward towards responsiveness, as well as in the development of protections and more resilient technologies. The year 2024 promises to bring more answers about our Sun, and we will continue to follow the incredible interplanetary movement because Earth echoes life out there, and we are all connected in some way. If you enjoyed this content or learned something new, write Earth Echoes in the comments. Also, don't forget to subscribe to the channel and share this video with a friend passionate about the universe. Until the next solar storm.